Hello, good afternoon to all of you. I hope all of you are doing well. So in today's class, we'll discuss about swapping using call by reference. Okay, so here I have declared a variable swap that takes in two pointer variables, right, and returns nothing. So here, just see, I have declared two variables, value and val_b, and I've read values into value and val_b. Then what I've done is I printed the values of value and val_b. So if value is 5 and val_b is 6, it will print 5 and 6. Then I have called the function swap by passing the address of value and val_b. So when I pass the address of value and val_b, that address will be received by pointer. So val_x is a pointer here and val_y is a pointer here. So val_x is a pointer to val_a and val_y is a pointer to val_b. So now what I'm doing is I'm printing the value of val_a and val_b through val_y and val_x and val_y, because val_x and val_y are reference to val_a and val_b. So now I'm swapping the content of the memory location pointed to by val_x and val_y. That implicitly means you are swapping the content of val_a and val_b, right? So now what I'm doing is I'm printing the values referred to by val_x and val_y, so it will print 6 and 5. Now once the function execution is over, so what will happen is that we'll have to come back to the calling function, then it will print the value of value and val_b. So here, once I print the value of value and val_b, it will print 6 and 5, because now what has happened is the content of a and b has been changed as a change to val_x and val_y. That basically means in case of call by reference, if you bring about any change in the formal parameter, the necessary change will be reflected in the actual parameter. So here val_a and val_b are the actual parameter. So in the x and y are the formal parameter. So any change brought about using the formal parameter will be reflected back to the actual parameter. Right? So that is in contrast to call by value, where call by, in case of call by value, the value is copied from one set of variables to other set of variables. So any change brought about in the formal parameter will not be reflected to the actual parameter. But in this case, any change brought about in the formal parameter will be definitely reflected to the actual parameter. Now what we have is we have next program that's capable of determining maximum of two numbers. But here, instead of using pointers, I'm using reference variable. So max is a function that takes into reference variable and it returns a reference variable, right? So max is a function that takes into a reference variable and returns a reference variable. So here again I have two variables, value and val_b, where I'm reading the values. So max is a function that returns the maximum of value and val_b. So here x is a reference to val_a and y is a reference to val_b. That means x is aliased to val_a and y is aliased to val_b. That means x and y can be alternately used to refer to a and b respectively. So now I'm passing the values of I'm passing a reference to val_a, that is to val_x, and reference of val_b to val_y. So now what I'm doing is I'm comparing the values of val_x and val_y. So now whichever is maximum, what I'm doing is I'm returning that particular variable. Now that is being initialized to Pmax. Now Pmax is again a reference variable, but it's different than that of a pointer variable, because a reference variable has to be initialized at the point of declaration, and second thing is it can be initialized only once, whereas pointer variable can be declared and initialized later, and pointer variable can be made to point to variable can be made to point to different variables. So here Pmax is a reference variable. So here Pmax is being initialized with the maximum of val_a and val_b through val_x and val_y. So now it will print the maximum of two values. So this is a very simple program using reference variable. Now inline function, as we have learned in the theory class, that inline function is a function that if called is replaced with the function definition at compile time. This is done in order to save the overall execution time of the program by avoiding the overhead of linking and returning. So inline function is a function that is replaced by the function definition during the compile time. So whenever you call a function, it's replaced by the function definition at compile time. So you have the additional overhead of linking and returning being avoided. So here you see we have functions, so get, sum, difference, product, division. So this is a very simple C++ program that implements a digital calculator, but the functions here are defined as inline function. So whenever function these functions are called, these functions will be replaced by the function definition. So just see here, get will get the values of a and b, but it's an inline function. Sum will add up the values of the two variables. Difference, minus will find the difference of two variables. Then product will find the product of two variables, right, again, and then division will divide one number by the other, and just see all these. So now I have an object of type operation where S is the object of type operation. So using S, I'm trying to call the member functions, but all these member functions are inline functions. So the member functions will be replaced by the function call will be replaced by function definition at compile time, right? So this is an example of inline function. Now default parameter. Now we have learned about default parameter in the theory class, but here let us try to understand it once again. So default parameters are parameters which if the values are not provided, then the default value will take its part in the execution of the function. So you see here we have four parameters x, y, z, and w. So z and w are initialized with default values 0 and 0. It can be the default value can be anything, right? Okay, any value. So now in the first case, you see I am calling a function sum. I'm calling a function sum by passing 10 and 15. So 10 will get copied to x and 15 get copied to y, and it will take default value for z and w, that is 0 and 0, right? Okay, so it will be 10 plus 15 plus 0 and 0. Since we have not provided value for z and w, so it will take the default value. In the second case, we have provided value for 10, we have provided value for x, y, and we have provided value for z. So this 25 will override this 0 value of z, okay, right? Whereas w will remain 0. So it will be 10 plus 15 plus 25 plus 0. In the third case, we have provided value for x, y, z, as well as w. So 25 will override this 0 and 30 will override this w. So in the first case, the sum will be 25. In the second case, sum will be 50. In the third case, sum will be 80. Because you see, the sum function has been defined as a function that returns in the sum of x, y, z, and w. Now we have the 29th program, which tries to show when overloading cannot be done, right? So this is a very simple program where we have two functions by the same name, right? Again, and but the return type is different, okay? But the return type is different, and here I've made a function call. So in such situation, function overloading cannot be done. So this is the second instance when what we cannot do is we cannot overload a function because we have static member function here, right? So this is one of the properties of static variable, or that is that if a function returns static, then what we cannot have is we cannot have function overloading working for it, right? So now to see in this particular class, what we've learned about is we have learned about swapping of two values using call by reference, where we are passing the pointer. We have tried to understand reference variable with the help of an example that determines maximum of two numbers. Then we moved on to inline function, where we tried to define the function inline, and we learned about what are the advantages and limitations of inline function, right? Then we moved on to default parameter, right? What is the role of the default parameter? So here we have learned that if the values for the default parameters are not provided, then the default value will be taken into consideration for execution of the operation or execution of the function. Then we learned about two different instances where function overloading cannot be performed. So we'll call it a day. Thank you very much.